Hello everyone, welcome back to Coding Intuition. Today we are going to solve minimum path sum question on LeetCode. So let us first try to understand what this question wants to say. So in this question, we are given a 2D array, basically a grid, as shown in this picture. So and we what we need to do in this question, we need to move over this grid, and we can move either down or to our right. So if we are standing at, let us say, 0 0, we can either move to this place or we can move to this place. Okay. By doing this from every node, we need to identify a path by going at which we will have the minimum sum at the end. Basically, the cost of going from here to the last node should be minimum. So we have to start so in this question we have to start from the 0 0 place in grid, and we have to reach up to n minus 1 and m minus 1 place in the grid, and we can only go down and right, and we need to identify the minimum path. Okay, so as in this example, this is a minimum path. For example, if we have chosen this path, the sum would be 4 plus 2 6 7 8 9. So the sum would be 9, and but in this case the sum the if we have come from this highlighted path in orange color, it is 7. So that is what we need to find. We need to find a path from which the sum of these values inside the grid would be minimum. So that is what this question is. Now let us just move to solution and try to understand the intuition behind it. So the first thing that might be coming inside your mind is that we might be go greedily all over the grid and try to find out the answer, but that would not give us the right answer. So let us just try to do it greedy, try to do it with greedy approach. So let us just see which is minimum among both of these 3 and 1. If we see minimum among them, we will go move to 1. Now if we see minimum amongst as we know, we can only move to right and down. So minimum amongst 5 and 4 would be 4, so we will again move to this. And if we try to find the only path we can go now is at 2 and 1. So this will not give us our optimal answer. This will give us our answer is equal to 9. So that tells us that the greedy approach won't work in this case. So we need to find out any another approach to do this. So let us just consider going considering every path and seeing which have the minimum value. So basically, what I'm trying to say is that let us consider going everywhere. We have two choices from every node. Either we can go left, or either we can go right, or we can go down. So let us consider all of them. How can we do that? We can do that by using recursion. So we can do it by using recursion. So and how we will be performing recursion over it to consider each and every path. So in this basically in this recursion tree, you can see that let us start from the index 0 0. Basically the let us say the variables for this is I and 0. So I and j both are 0 in this case. So our column number and our row number is both are 0 in this case. So what we will be doing is we will increment I in one case, and we will increment j in another case, and we will do the same recursively until and every time we are going ahead, we will keep adding this value inside our answer, and at the end we will consider the minimum, and whenever we are going on these two choices, while adding the value of this guy here, the value of this guy is 1. While adding something to this value, what we will be doing is we will be saying what is the minimum, what is the minimum of these two guys. So, what is the minimum of these two guys, whatever these two guys has got up to here. So we will consider the minimum of these two guys. So that is what we can do in our recursive approach. But uh, um, as you can see in this recursive approach, will not be the optimal approach, because there are n nodes, and can let us consider there are n nodes, and that and we will be iterating over all of those nodes. So in that case, the time complexity would be 2 raised to power n in this case. So that and in that with that time complexity, we will not be able to pass all the test cases for this question. So we need to do something else in this question as well. So what one other thing we can do in this question, that as we go downwards in the recursion, we can see that in every step of recursion we will be doing the same thing. Basically we will be just calculating the minimum of these the next two guys, and adding that to our the parent in this tree. Okay, so we will just doing the same thing, and we will always be incrementing I once and j once. Okay, as we have done here. So if we go more down in the recursion tree, I've just drawn the part of it here. But if we go more down in the recursion tree, we can see more similar instances like this, that we are repeating our calculation. Sometimes we can, if we store them in some memorization array or in some dp array, we can skip some of the calculations. By doing that, we can store this repetitions inside our dp array. So basically what we will be doing, in whenever we encounter something, we will store that in our 2d array, the solution for that in our 2d array, whatever the minimum value up to this point, we will store that in our 2d array, let us call that array dp, and that we will use to memorize our solution. And so that would be the second approach in this case. And don't worry, I will be showing you all three codes that will go from recursion to memorizing this, and then to then at last we will be using bottom up dp. So now let us just move to understanding bottom up dp approach. So in bottom up dp approach, what we will be doing is we will try to consider the minimum values from the top and the right element near to us. So for example, what we will be doing here is we will just consider that whatever is the minimum amongst my top and the previous value here, I will add, I will use that here and add it to the current value here. Okay, so let me just show you it by an example. What we will be doing is, so for the first element, we will just put for the zeroth place, we will just put one as it is. So if there is only one element inside this grid, so that will be our only choice. So that so we have to choose the 0 0 because we have to start from it. Now as we move ahead, what we will be doing it, we will just add the this 3 plus 1 is equal to 4. So we will just add the previous element because there is nothing on the top, so we cannot choose amongst anything. So we have to go on this path only for right for now. Now as we go ahead, we will just add one another element to it, that is 1. So we had added 4 plus 1 is equal to 5. Now as we go down, now again we have only one choice. We don't have any element to the left of it, but we only have an element at the top of it. So we will just add a value 1 to it. Okay, so here we have two. Now what we will be doing is we will be looking at these two values. Whatever is the minimum among these two values, we will add our current value to that. Okay, so now what we will be doing is we will add 5 to the minimum value among this. The minimum value among these are 2, so we will be remaining with 6. Oh, sorry, 5 plus 2 is 7. So we will be remaining with 7. So we have 7 here. So again, we move ahead and we will choose the minimum value amongst both of these. So among 5 and 7. So among 5 and 7, 5 is minimum. So 5 plus 1 is equal to 6. So we have added 6 here. So now as we go down, we will again see the top element and add 4 to it. We will be remaining with 6 with here. And now we have two choices. Again, we can choose the minimum amongst them. The minimum among them is 6. So we will choose 6 and add 2 in it, so it will become 8. Now we have 8 and 6 here, so we have to choose again minimum amongst them and add 1 to it, and that's how we have our final answer 7. So that is what we are going to do in bottom up dp approach. So let me just show you all three codes for recursion, memorization, and recursion, and then bottom up dp approach. So that will make this question very much clear to you. So first, let's look at the recursive code for this. So inside the recursive code, firstly we are getting the number of rows and number of columns like this, and then we will call our recursive function. So inside our recursive function, we are doing if we go out of bounds, if I is less than 0, j is less than 0, that will happen in the case when let us say we are at in the first column. In first column, when j is equal to 0, then when we decrease I, we will get to minus we can get to -1. So in that case, we just need to return -1 for the I case, and we will just add j in that case for the first row or first column. In that case, we will just return int max, so that this minimum will consider only the other value. So that's why we are doing this here. And if both are equal, we will just return the value of the grid, basically, that is both are equal to 0, basically that is the first value in our grid. And after that, we will add the current value of our grid, and we will say either go to I -1 or j -1 and find out the minimum amongst them. So that is the simple recursive code. It is explanatory by itself. Now let us just convert this to dynamic programming code. So in the dynamic, in first of all, let us just look at the top-down dynamic programming approach. So here we have just saved whatever we are returning, in that case, to our dp of ij, and we are basically just checking if we have already have the answer for this index I and this index j. We will not redo that. We will just check if it is already existing. We will just return that. How can we check that? We will just initialize this dp array. We will create a dp array which have equal dimensions as of our grid, and we will initialize all of its value to -1. If its value is -1, then we didn't found out this value yet. We will go ahead and find it, and if it is not -1, that means we already found out the value for these indexes, and we don't need to calculate that again. So that will reduce our time complexity, uh, uh, and that's how we will do top down DP approach. Now let us just move to bottom up DP approach. So in this case, we will just iterate over array, and here we will do the same things as we have done in recursive approach. First of all, if the it is our first element, which is basically the 0 0 index for both I and j, we will say the first element is added to our DP of ij, and else if we are inside I is equal to 0, means if we are inside our first row, we cannot go to I minus 1. That's why we are just saying if I is equal to 0, just say it int max, and if j is equal to 0, we cannot go to j minus 1. In that case, we will say int max, so that it will consider the minimum of that, obviously, because other value is int max. So that is what we are doing here as well inside our top down approach also. So that is the explanation of these three approaches, and in bottom approach we will simply write on the last element as we have seen on whiteboard. So I hope that makes the explanation of these three approaches very much clear, and that's how you should approach dynamic programming questions in general if you want to get to know the intuition. Because if first of all, if you write the recursive code, because recursive code is in most of the cases is in itself is very intuitive, and then you have to come up with the top down DP, and then you have to convert it to bottom up DP. That's how you will get the intuition behind this dynamic programming questions. So I hope this question has helped you. Thank you so much for watching. Bye bye.